This is a Leaving Cert higher level sample paper question from 2014. In the first part, we're just to evaluate f of 0.2. So we just sub in 0.2 for x. And when we do, we see the answer is 0. In the second part, we're to find a maximum point. At the maximum, the derivative equals 0. So let's differentiate. We reduce the power and multiply by the whole power. This tells us that minus x plus 5 equals 0, so x equals 5. And this is what we wanted because it says the max is at 5, 11, 52. So sub in 5 into the original function and evaluate this, and we see that yes, it's 11, 52. So this is a turning point at 5 and 11, 52. Well, how do we know it's a maximum? Well, just because it's a negative quadratic, it must be a maximum. We could also get the second derivative and show the second derivative at this point is negative. Okay, in the second part, we're to draw a graph of this sprint race, and it's broken up into 3 parts. For the first 0.2 seconds, no distance is traveled. He hasn't moved yet. So we'll just mark that off. In the second part, it's a quadratic. We could sub the points into the calculator using the table function. So we get f of 1, 2, 3, 4, and 5. Now we already know f of 0.2 is 0 and f of 5 is 11, 52. We could sketch it in a hurry just as a curve between these points. But we'll get it more accurate if we have to use the points here that we've generated from the calculator. So mark off the x and y values. And as we expect, it's going to be kind of part of an N-shaped curve coming up to the maximum. So just join the dots here. And something like that. It is a sketch, doesn't have to be 100%. And the last part of it, after 5 seconds, it moves at this constant 1152 meters per second. So we just mark that off. So there's the shape of the curve. Very nice question. Okay, now we're to find the distance traveled in the first 5 seconds. Now the distance is the area under a curve in a velocity time graph, because velocity multiplied by time is distance. So we're just marking off here just a picture. So the distance we're trying to get is this area I've colored in pink. And we see the limits here. It starts at 0.2 and goes up to 5 seconds. There's the limits. So we're going to integrate this function because the area of the curve between the limits b and a of f of x dx. So our limits are 5 and 0.2. Our function is the function given in the first part. Just writing it out here. And we're going to integrate that. When we're integrating, we're increasing the power by 1 and dividing by the new power. And it's good practice to put on plus c at the end, even though in this definite integral the c will disappear. Now I'm very quickly just going to evaluate this. Putting in the values 5 and 0.2. We work this out. We see the answer is 36.9 meters. Okay, in the last part, we're to find the time, the total time to run the 100 meters. I'm going to break this journey up into 2 parts, really, because there's the time to run the first 36.9 meters, the kind of quadratic curve as he's speeding up, and then there's the time for the remainder of the race. So I'm going to call the first part, I'll call this part A, that's the easy part. Call that part, and the second part we'll call that part B. So it's good to put labels on what we're doing. So if we consider the time for part A, well, that's the easy part, we know it's 5 seconds. In part B, we'll have to work out the time. Now the formula here, you might remember from junior cert science, is Dad's silly triangle, which tells us time is distance divided by speed. In this case, the distance is 100 minus 36.9, and the speed is 11.52 meters per second. Stick this into the calculator, and we get 5.48 seconds. So the total time is 5 plus 5.48, or 10.48 seconds. Thank you. I hope this was useful.